Looks like we're live. Hello everyone and welcome to yet another recreational programming session. How about it? So let's make a little bit of an announcement and officially start the stream as usual. Hello, welcome. So what we're gonna do red circle live on Twitch. And what are we doing today on Twitch at .television website? Today we're doing hot reloading in C. How about that? I think that's a very interesting topic at twitch.tv/Tsoding. This is the place where we're doing all that. And I'm gonna ping everyone who's interested in being pinged, and there we go. The stream has officially started. The stream has officially started. Hello, welcome. So in fact, today we're going to continue developing the music visualizer that we started on the previous stream, right? So if you saw the previous stream, you probably remember a thing like this. So essentially, this is like a the basic equalizer music visualizer, at least an attempt at implementing that. It looks horrendous, I know, right? And this is because we're not mapping the frequencies properly. We're gonna fix that. Probably today, by the way. We're gonna probably fix that today. So the main thing that I want you to have in this project, I want you to be able to quickly iterate on the visuals, right? So right now, if I want to change something, I have to recompile the entire project and then run it again. And since it's a musical application, that means that the music is gonna start over and over again, and it's not particularly pleasant to watch or listen to. So essentially what I want you to have, I want to be able to modify something within the source code and restart, sort of reload the behavior without restarting the song. So I want to be able to like develop the application while the song is playing. Right, and I think it is possible. The way you usually do that, you basically hot reload the implementation. It's rather easy to do in dynamic languages, right? Like Python or JavaScript or even Java, right? So Java, even though it's compiled language, it's actually still dynamic because it uses some fancy virtual machine. So, and that virtual machine actually allows you to reload the source code. So, but the thing is, you can do the same thing in C. You can do the same thing in C. So essentially, this is why such mechanism as shared libraries, or as people call them in Windows, DLLs, exist. Right. So being able to dynamically load code is actually basic mechanism of any operating system. So DLL stands for dynamically loaded library. The DLL, the abbreviation DLL itself actually describes you what it is, right? So being able to dynamically load the code is basic functionality of any modern operating system. And this is what I want you to utilize today. This is what I want you to demonstrate today. I want you to demonstrate that you don't really need these fancy dynamic languages, these fancy virtual machines, just to be able to hot reload the code, right? So this is the technology that existed since, maybe 70s, I don't know. So it's just like, yeah. So interestingly enough is that, like, there's nothing magical about that. Because the code, it is stored in the memory. So if you want to load the code dynamically, you just load that code in memory and you just jump the execution there. That's it. So, and this is something that existed for ages, right? It's not some sort of like a magical technology on the level of like AI progress or whatever the fuck it is, right? So it's a very old technology, yet people still surprised by framework that hot reload things like on the fly, and like, holy fucking shit. No, it's old technology. There's nothing to be hyped about in here. So yeah, let's actually try to do that. So first of all, we probably want to create the the dynamic library that we're going to be actually loading and stuff like that. Right, so here we have Mutualizer, which is basically the entry point of this entire stuff. We probably want to create some sort of like a separate module which is going to be compiled to a dynamic library that we're going to be loading into the main program, right? So I want to call this something like I don't know, let's call it plug, right? So it's sort of like it's going to act like a plugin, right? It's going to act like a plugin. So, and I already created a header file. So I'm also going to create the C file as well. So let's do the inclusion guards. So the inclusion guards are needed so you do not accidentally include the header twice. And let's create like some sort of like a test function, some sort of a test function. So let's say plug hello. And what this thing is supposed to do, it's supposed to say hello to the caller of this function, right? So it's supposed to print hello to the standard output. Right, so let's actually create plug.c, right? So you need to have header and C file because this is how C works. You don't really have to, but this is sort of like more of a convention, right? So it makes it easier to have like a list of all of the declarations and then separately in a separate file all of the implementations of the declarations, right? So it's sort of like a convention that C developers developed a long time ago, but you don't really have to do that. So anyway, we're going to include plug.h, and in here I suppose we probably also want to include something like std.io, so we can actually print stuff in them. And in here we're going to say something like hello from plugin, right? Hello from plugin. So we can go to Mutualizer, and maybe one of the things we can do, we can basically call this function like right away, plug hello. I'm also going to include the header in here, right? So this is going to be plug.h, and below executes the main program, right? So it parses command line arguments, it initializes arraylib and stuff like that. We don't really need any of that stuff right now. So I'm going to just do return 0, which means that it's going to only call plug hello, and as soon as it goes here, it will just exit, but we don't remove that code because it's going to be useful in the future, right? So I just don't want to remove this code, I want to disable it because I'm just experimenting with the plugin system and stuff like that. All right, so let's try to rebuild this entire stuff. So I'm going to do build.sh, and there we go. And we have undefined reference, and this is because we do not link with the plugin. Right, so we're supposed to make, dynamic library out of plug.c, but before we do that, let's actually just test that our entire thing works. Let's actually like statically link with that plugin. And if it works while being statically linked, then it would be easier to make it work while it dynamically linked, right? So let's actually do src plug.c, there we go. We're literally statically linking with this entire stuff. Let's try to compile. As you can see, it compiles, everything is fine. And then we can try to run Mutualizer, and it should say hello from plugin. So it says hello from plugin. Isn't that cool? Isn't it cool? I think it's pretty freaking cool. So we got some subs while I was doing an intro, so let me quickly acknowledge them. Thank you everyone who just subscribed. Thank you so much Luke Haas for Twitch Prime subscription with the message DLLs in 2023. I know, right? So DLLs in 2023 is something unheard of, right? You're supposed to program everything in JavaScript, and what kind of, like, what is even DLL? Just have a separate JavaScript file and you're good to go. Starkey, thank you so much for Twitch Prime, and Subin, I hope I pronounced your nickname correctly, thank you so much for Twitch Prime. Brooklyn Dev, thank you for Twitch Prime as well. So everyone using Twitch Prime, does anyone actually uses like actual Twitch subscriptions anymore? Or is this all about the primes? So, but anyway, thank you so much. And with the message, keep the streams coming, man, thank you. Well, thank you for watching them. Thank you. All right, so we have this thing. So we need to turn it into a shared library, right? So we need to turn this entire stuff into a shared library. So let's actually modify the build script. So let me see. we need to do clang. I probably want to include some C flags, but C flags actually include stuff related to Raylib, and I'm not sure if I want to actually, well, maybe we'll need Raylib related stuff in the plugin, right? Because it's that specific plugin, that specific DLL is going to call to Raylib, right? It is going to call to Raylib. So the idea, I wonder if I can actually draw, like I didn't bring my tablet with me while I was moving to this apartment, but we can actually try. Right, so I can try to run my paint and see if I can actually draw with my mouse. It's not even a good idea, I don't know. Let me, where's my, okay, there we go. So essentially, right, we're gonna have a Mutualizer, right? So this is the Mutualizer. Right. So at least I can draw the straight lines without any tablet, which is, well, I mean, almost. So this is the Mutualizer. And we're gonna have plugin, right? We're gonna have plugin as a separate sort of DLL thingy. So on Linux, it is called shared library, so SO. I'm gonna call it SO in here, right? So something like this, and Mutualizer is going to call to plugin, right? It's going to periodically call to plugin because it's going to contain the logic. So my idea is going to be that the main event loop is going to locate it within the Mutualizer, and then each frame is going to be called to a plag.so. Right, it's going to be responsible for rendering a single frame, the logic of a single frame. And that way, reloading this entire thing is going to be actually, it's going to preserve the state of the application, at least some of the state, because the main problem with hot reloading the code is that you may lose the state. And preserving the state is actually super important for us because I want to be able to modify the visuals while the music is still playing, right? Because constantly restarting the music is extremely annoying, not only for you, but also for myself, right? So I want to be able to just listen to music, get into the flow and stuff like that, and just like modify the visuals, right? And like slightly adjust without restarting all of that. That would have been ideal, right? And on top of that, we're also going to have a Raylib. So this is going to be Ray. Oh, look at that. If I enable auto smoothing, right? So I can actually draw with the mouse. Can you believe that this was actually drawn with the mouse? By the way, you've probably seen like a lot of artists drawing smooth lines, and they're just like so freaking perfect. I'm gonna tell you a secret. A lot of these, you know, drawing programs, they have auto smoothing, right? So this is with auto smoothing, and then if I disable smoothing, this is how it looks like, right? So all of these smooth lines that the artists draw is actually a lie. It is straight up lie. It's actually AI technology. So we had to train like a neural network to recognize the strokes and like interpolate the lines and stuff like that. But don't tell anyone. We actually trained that AI on the copyrighted data, on the copyrighted work. So don't tell anyone that I'm using this kind of thing. So, anyway, so we're gonna have a Raylib, and I suppose both of these things are gonna be calling to Raylib. Right, so Mutualizer is going to call to Raylib on each iteration. It's going to even initialize the window and stuff like that. And Plug also going to use this entire thing. Plug is also going to use this entire thing for drawing. Right, it's going to call to draw a rectangle, at least because we're drawing a lot of rectangles and stuff like that. So this is basically the architecture of this entire stuff. Right, and because of that, I think the Plug SO needs the C flags related to Raylib, because both of them are going to use Raylib. So let's go ahead and actually do C flags. And I suppose I'm going to simply just like provide this entire thing in here. Maybe we're also gonna link with libs. And if I remember correctly, if I remember correctly, you have to provide the shared flag, and that will automatically create the SO file. So on top of that, it's quite important to generate position independent code, right? Position independent code, because it's basically the code that can be placed anywhere in the memory and it will still work. Right, so it does not really depend on any absolute addresses or anything like that. It uses like relative addresses to jump and everything. So when you're making a shared library, I heard that it's the best to generate position independent code. It kind of solves like a lot of different problems. So, okay, let's actually test building only the shared library. So I'm going to do exit here like this. Basically, I'm going to disable everything after the exit. So I really like doing this kind of trick, right? So when I'm testing something within the environment of the program, I want to disable like a huge chunk of code. I just like exit before I execute this entire thing, and then I can enable it back by just like removing this entire thing. Right, let's actually disable everything down below. And let's try to build this entire thing. So usually, by the way, this is quite important. I recently added build folder, so I put all of the build artifacts into this build folder. So I think it would be nice to do the same for the shared library. So we're going to do build, and let's say this is going to be build plug.so, and let's just go ahead and try to run this entire thing and see if it's going to do some stuff. Okay, it's successfully exited, and if we take a look at what we have in here, we've got plug libplug.so. Right, so we can take a look at what kind of thing it is. So it's a ELF64-bit LSB Pi executable. Interesting. Dynamically linked with debug info and stuff like that. So we can also take a look at what kind of stuff it depends on. It depends on all of the dependencies for raylib. Right. It does not depend on raylib because raylib is not dynamic library, which is, by the way, rather interesting. Raylib is statically linked, but I do plan to use raylib from both the main program and the shared library, but they link with raylib statically separately, and raylib has like a global common state. Will that create a problem? That is rather interesting. So because maybe we need to compile raylib like dynamically as well. Right, so we can take a look, like just a second. OPT raylib. What kind of stuff do we have in here? We only have a static library. Do we have any SO files in here? So it's going to be file name SO. No, we don't actually. We actually don't. That's very unfortunate. But let's just continue. Let's just continue with this kind of stuff. We've got another sub. Thank you so much, Rainy Roxai, for tier 1 subscription with the message no prime. Right, so everyone subscribed with the prime, and you, the first one who subscribed without any prime. I really appreciate that. Real money, not imaginary Bezos money, but actual, really, real money. All right, so let's continue. So this is a plugin SO, and one of the things I want to do, I think I want you to take a look at the symbols from the plug SO. Do we have hello? Yeah, there we go. So we have a plug hello, right? So now what I want to do, I don't want to link with plug.c, right? So now if I try to build this entire thing, it is not going to build because it won't find this stuff, right? So undefined reference plug hello. But now I can try to link with the plug, right? Can we link with the plug? We can't really link with the plug because it doesn't know where to search for the libraries. So one of the things we probably need to do, we need to say that search for the libraries within the build folder. Right, so we just use the build folder and search for the libraries within the build folder. Let's try to run it one more time, and it works. Right, so we're not linking with the plug.c, but we're linking with the plug SO. We're linking with the plug SO, and if we try to run the Mutualizer it says that while loading shared libraries, libplug.so cannot open shared object file, no such file or directory. Well, at least we know that it tries to look for libplug.so. It couldn't find one, but it was looking for one. Right. So as far as I know, I think the easiest way to fix that, I think you can specify like the search path at the compile time, but at runtime you can use ld library path, right? You can use ld library path and you can specify, okay, search for this thing within the build, right? So search for this thing within the build, and right, that didn't really work. Maybe that's pretty surprising. Is that because LD library path? So if I take a look at LDD, does it depend libplug? There we go. So libplug is located in here. So let me see. I probably need to try to do LD library path. So build, and then let me do visualize it. There we go. Hello from plugin. So I suppose what's the difference? Oh, this is because I actually put double ampersand in here, and yeah, so the double ampersand has a different meaning here. So if I remove that, it says hello from plugin. Okay, so everything's fine. But our goal is to actually not even link with the libplug. We want to be able to load it dynamically. So here we're still loading it at compile time. We're still linking it. But what we want to be able to do, we want to be able to actually find this library at runtime and load all of the symbols at runtime. So we need to detach this library even further from the main executable. So we'll get another sub from voidman.ger. I hope I pronounced your name correctly. Thank you so much for tier 1 subscription with the message большое спасибо for your streams. They contain so many teachable moments and are really entertaining. I'm really glad that it is like that. Thank you so much for the subscription. Thank you. All right, so how can we do that? How can we dynamically load this entire stuff? This is a very interesting question. Well, POSIX systems and Linux specifically, they have a pretty cool thing called DLOpen, right? So essentially, DLOpen accepts file path, basically path to a SO file, and some flags, some configuration flags and whatnot, and then return you the handle of the dynamically loaded library. Right, it's a void star, but that's besides the point. You can then feed that handle into things like, I think, DLSym, right? So you can look up the symbols within that dynamic library. And for instance, if you know the name of some functions, you can say, okay, find that function within that library that we just loaded, and it will return you another pointer, which is going to be pointed to the function or a variable so that you can use, right? If it's a function, you can actually cast that pointer to the corresponding type of the function and call it, and it will actually call that function from that library. So, and then if you decide to reload this hot library, or hot reload this library, you only need to close it and just DLOpen it again and find all the symbols again, the new symbols, and it will just work without restarting the library, right? Because it's a basic mechanism of any modern operating system. So let's give it a try. Let's give it a try. So this is awesome technology. When was it created? I don't really know. Is there any year in here? Probably not. So 2017, but I mean, this kind of technology existed like for quite some time, right? So I don't know, maybe 70s? Probably not, maybe 80s, more like 80s. So anyway, let me go ahead and try to do that. So the thing we're gonna do, we're gonna even not link with libplugin. We're gonna not even link with libplugin. So, but here is the interesting thing. if we try to build this entire thing, right? If we try to build this entire thing, it's not going to even build because it still tries to link with this function call. So what we'll have to do, we'll have to turn this function that we have in here, we'll have to turn it into a global variable. Might as well actually keep it somewhere here, right? So we can turn it into some sort of like a global variable, like so, plug hello, and initially it's going to be null. And essentially what we want to be able to do, we want to be able to load the library and just populate this function. Okay, so let's actually organize it slightly differently. I'm going to keep that pointer in the main program, right? I'm going to keep it in the main program. And in here, in the header, I'm going to only define the type def of the function. We really want to know the type of that function because we're going to be casting the pointer to that function, so we are able to even call it. Right, so as far as now, you do it like that. So you do type def, and then you just use this syntax. That way you basically define a new type def, a type alias, which is the type of this function, right? This is the type of this function. Since we're not statically linking with this library anymore, we don't really need the actual signature of the function. We don't need the declaration of the function, but we do need the type of the function because we're going to be casting the pointer to that function, so later we can call it, right? So, and maybe on top of that, I want to call it something like plug hello function, right? Plug hello function, or maybe T. Right, so this is a very usual convention in C to call types underscore T at the end with the suffix underscore T, so we know it is in fact a function. So then later here I can say, okay, plug hello T, and this is the variable that holds the pointer to that specific function. So right now, if I just try to call this function, I'm pretty sure it's going to segfault because we're going to be trying to call null. Right, so let's try to do that. So it compiled successfully because we're not really linking with a specific function, right? But we still know the type of this function. And if I try to run this entire stuff, build mutualizer, right? So this is going to be a build mutualizer. It is going to segfault, as you can see. It segfaulted because we tried to call a null pointer. And that is not something that you're allowed to do in this specific environment. I don't think you're allowed to do that, right? And that got confirmed very, very quickly. So the first thing we probably want to do, we want to load the library. So let me see. Let's actually have the pointer to the name lib plug file name. So, and let's say libplug.so. I really want to have like a library because I'm going to be using that name in reporting errors and stuff like that. So it's better to have it somewhere here. And let's go ahead and just try to do DL open on this thing. So the thing we have to provide the name, right? And we have to provide the flags. And the flags are pretty simple. So there are two mandatory flags, right? So you have to choose between RTLD lazy and RTLD now. And essentially, lazy performs lazy bindings, resolve symbols only as the code that reference them is executed. I suppose we don't really care. Right? I suppose we don't really care what we want to do. We just want to load all of these things as quickly as possible, right? We're not going to have too many of them. So, and because of that, I'm going to put our RTLD now. So, and we're going to be saving that to this thing. In case of an error, this thing is supposed to return null, right? So if you take a look at the return value, on success, on error, these functions return null. And as far as I know, you can also call to DL error to get the string with the description of an error, right? With the description of an error. So let me see. LD lazy, LD now is only important for large libs with multiple dependencies and such. Yeah, That makes sense. We don't really have too many dependencies, so I don't think it's relevant for us. So because of that, I'm gonna just say like now load everything right here, right now. And as soon as it starts to, you know, cause problems, maybe we're gonna look into that a little bit deeper, but I don't think we'll need to do that in the near future. So if we couldn't load this entire thing, it should return null. So let's actually check for that. So maybe we can do something like std error could not load s because of s, right? And essentially I'm gonna say could not load file name, and then I'm gonna call to dl error. So and I think it just returns the string to the last error. I don't know what the fuck is going on outside, but I'm not even sure if you heard that. Obtain error diagnostics for functions in the DL Open API. Okay, so that's actually very useful. DL error, like this, and we're gonna just return 1 in here. Woof, yeah. So somebody's barking outside. All right, so that seems to be good. We can try to just build this entire stuff and run it one more time. Okay, so it complains about things. It cannot find DL open. So one of the things we need to do, we probably need to include one of these things, which makes it not particularly cross-platform anymore. And that's what's interesting. Right, so far, this entire thing was rather cross-platform. We were only depending on the libc and the raylib, and both of these libraries are, you know, they work pretty much everywhere. But this thing is very much POSIX specific. So if you want to run this kind of code on Windows, you need to use Window API, right? So you need to use the Window API. And maybe this is something that we can do in the future, right? So maybe we can just write a simple abstraction layer that abstracts away a specific operating system mechanism for dynamic libraries, right? Because on Windows, you kind of do a similar thing, actually. You kind of do a similar thing. It's just like you call to different functions, right? With slightly different signatures, but ultimately it's the same. Ultimately, you just provide the file path, you just get the handler, you search for symbols in that library, and you just like cast them to specific types and you just call them, right? So it's pretty much the same on any operating system. It's just like the names are different. Yeah, so exactly, thank you so much. Load library W and get proc pointer or something like that, right? So it's just like so everyone tries to vendor lock you, right? Every platform will create their own version of the same API. So you write code for that platform, you can't use that code on a different platform. So, and they do that intentionally, by the way. They literally do that intentionally. So if you have like a very useful application, it should work only on that specific freaking platform. So in a civilized society, this kind of shit should be illegal, but let's not go into that. Anyways, so let me see. So what I want to do, yeah, there we go. So we probably need to specify. So it says it cannot open libplug.so. I wonder if LD library path actually affects the behavior of DL open. I never thought about it, actually. That's very interesting. LD library path, and I'm gonna say, okay, look for the libraries in here. Okay, so that worked. It's still segfold because we still call to the null function, but this part actually succeeded. This part actually succeeded. The next thing we need to do, we need to look up for the what the fuck is this shit? Sorry. For the symbols. So let's actually find DLSym. And so the way we're supposed to use that, we have to supply the libplug, right? And the symbol is going to be plug hello, right? Plug hello. And essentially we can straight up like assign it to plug hello. And again, DLSym may return a null in case of an error, right? So if we do plug hello equal to null, we have to say that we couldn't find that symbol in that specific library, right? So we have to say something like std error could not find plug hello symbol in S. So I'm going to provide, so this is supposed to be error libplug file name dl error. let's just say 4, and we're gonna just return this entire thing like so. Okay, so and after that, let me see what is going to happen. Okay, first of all, it worked. It says hello from plugin. Hello from plugin. So we need to provide the S in here. Okay, that's pretty cool. Now, I want to test the hot reloading, but it only makes sense if you have the event loop, right? It only makes sense if you have event loop. So for that to actually work, I think we need to factor out rendering of a single frame into the plug. Right, we need to factor out rendering of a single frame into the plug. So let me try to do that. So yeah, I want to just take the entire body of this thing and move it into the share library. So then later I can actually call it. So let's define the function that renders a single frame. So how should I call this entire thing? I think I'm going to call it maybe plug update, right? Or maybe plug frame, right? So this is basically a single frame. So it's supposed to handle a single frame. Is it going to accept anything? It may accept something, right? So it may accept the state, some sort of a state. But we'll then have to define what is a state. We can define plug, which is going to store the state, and we're going to pass that state like so. We're going to pass that state to this specific function. So the question is, what we're going to store in there? So do we have some sort of a state to keep track of? I think we do. For instance, we have these global variables in here, right? We have global variables in here. On top of that, we actually have like a pi, which we sort of compute separately at the beginning of the execution. And the reason why we compute it is because we want to get the precise pi for 32-bit float. This is the thing that I learned from Fortran, right? So Fortran developers, depending on the level of precision that you have, you compute pi specifically for that precision, which I'm not really sure if is useful for us specifically, but I think it's kind of cool. So maybe this is like this global stuff is what we're gonna keep in the state of the plugin, right? So this is probably what we want to store in there. Let me actually see. Maybe I'm gonna just like literally put it in here. So this is basically the n. So this is the pi, this is input and output. These are just like input samples that we get from the sound API. And then we apply a fast Fourier transform on these samples, and we get the frequencies in output. And as you can see, they are complex numbers because this is how FFT works, right? So this is how FFT works. And we also have a max amplitude. So essentially we need it so we can scale properly the frequencies on the screen. But I'm not really sure if it makes sense to keep track of this kind of stuff in here, but we'll see, we'll see. We'll see. Alrighty. And let's actually go ahead and copy this entire stuff. But we also need to be able to initialize the sort of the state, before we go into the constant updating of that state. Right, so maybe we're gonna have some other function in here, which is gonna be called plug init, which is also going to accept the state of the plugin, this specific state of the plugin, and is going to initialize this entire thing. Maybe set something like to 0, or maybe like pre-compute pi, I don't know. Why do I keep pi like this? Right, so why do you even keep pi like this? I think Fortran literally damaged my brain irreversibly. And from now on, I want to like compute pi specifically for the precision of flow that I have, and it's just so fucking dumb. I don't know why I'm doing that. It kind of creates more problems than it actually solves. But anyway, so we've got some subs. Thank you so much, Iknak X. I hope I pronounced your name correctly. Thank you so much for tier 1. And Adentropy, thank you so much for tier 1 with the message love. Seeing you program. Thank you. Hot reloading pi. Yeah, so yeah, we're gonna be hot reloading pi. Isn't that Pogue? I think that's pretty freaking Pogue. Okay, guys. So what do I need to have in here? So this is just visualization and stuff like that. Oh, and by the way, we can also keep music. We can also keep music as part of the plugin state, right? So this is something that we may want to have. An initialization of the plugin is going to load the music, but hot reloading is not going to call init because this thing init is already kind of like called, right? So it's going to continue working on the same state. So essentially, like, how does it fit into this entire sort of architecture? So I suppose the music, when it starts, the visualizer, when it starts, it initializes the state, like so, somewhere in the memory. And I'm going to actually use a rounded frame as an opposite of a square one. Square one means that this is a library, and this is basically the data. This is basically the state. And essentially, visualizer just like uses this state, and plugin SO uses this state. And as long as the schema of the data in memory the same, you can quite safely keep hot reloading this thing. But the problem will start to arrive when you need to change the schema of that state. For example, when you need to add additional field into this structure. So how do you even handle that? That's going to be interesting, right? I was thinking about things like, I don't know, keeping track of the version in the memory, right? And then essentially, literally when you hot reload and the new code notices that it has a structure of the previous version in the memory, it can apply migration of that structure from one version to another one, just like for the databases. And this is actually a very cool idea. Do you guys know the database migrations? Right, so I think one database migration framework that I can remember off the top of my head, I think is Flyway migrations. Yeah, there we go. So essentially, you modify your code, right? Imagine that you're like being like a web developer and you have a backend, you have the database and stuff like that. Let me actually put this entire stuff in the description. So Flyway database migration framework. Is that a framework? Do they identify themselves as a framework? How do they identify themselves? Can I reject all? This is a goddamn... I can instantly see that this is a US website. This is a US website. Only US websites ignore fucking GDPR and don't supply the button reject all instantaneously. Right. So... save settings, I don't know. Anyway, so do they identify as the framework? So what is a Flyway, right? So maybe I'm gonna call it a library, right? So you don't deserve the title of the framework, right? So you deserve only the title of the library, right? And I'm gonna put it in here. What the fuck is going on? There we go. So essentially, you have a database with a specific schema, and then you update your code to work with a different schema. You deploy that code in production, but in production, the database still has the old schema. So before deploying your code to production, you need to migrate your database to a new schema so the application can work properly. So the way these frameworks work, this is not only framework, this is not only the only library, there is a lot of them because the concept is actually very simple. So you let your application migrate the database. You don't do anything. The application that you just deployed migrates your current production database. So what it does, it keeps track of the version of the schema in the database itself. Then as soon as the backend starts running, it looks at the version of the database and sees, oh, okay, it's an old version. And then before actually executing, first it migrates the database, and only then it starts working with this kind of database. So this is how these things work, and they're extremely freaking useful, by the way, right? If you never heard about this kind of like things, just learn them. They're extremely useful. They save a lot of work. Isn't how they all work? Yeah, this is how they all work, but I actually met people who never heard about this kind of concept, and they migrate database manually. Yes, right. So what's interesting is that this concept is very useful to know, because it is applicable not only to databases. For example, you can have an application, maybe a game, that uses some sort of like a data asset file, and that asset file has a certain schema, and you can use the same technique to migrate that schema as well. Or, for example, we can use a similar schema to migrate a structure in a memory at runtime when we hot reload the code, because fundamentally there is not that much difference between hot reloading the code and deploying the application, right? So essentially, you can think about this thing in a memory as database, and hot reloading as deploying your backend. And so your backend can notice that in the memory it has a previous version of the structure, and it can try to migrate that structure. Maybe like fill out the new fields and stuff like that. Maybe allocate more memory for a bigger structure. It can do some kind of stuff, and it keep running without actually restarting, and allow you to modify the schema of the structure. You know what I'm talking about, right? It's kind of a similar concept, right? And this is something that I've been talking about in the previous stream. So we did like a test stream yesterday, because I moved to a different apartment, so I wanted to test how this entire thing works. And I was talking about how programming is a universal thing. Programming is a universal thing, right? So programming is something that is applicable in front-end React development and the kernel driver development. Right. If you take these two disciplines, like React front-end development and kernel driver development, and you find an intersection between them, that intersection, that universal knowledge, is what I call programming. This is what I call programming. So, and when I say like learn programming instead of technologies and languages, this is what I mean. So there is something universal between them. There's something universal. And this is a freaking good example. The concept of data, right? Data having a scheme, and then migrating that scheme to a newer version applicable in databases and in hot reloading of a graphical application. So this is the universal, this is the essence of that knowledge that is universally applicable. You know what I'm talking about? You see that? This is an example of what I'm talking about. This is the intersection. You can think that like hot reloading a game and freaking backend enterprise database, like what's common between those things? Like, what's fucking common between them? Like, it's a completely different thing. No, they have like a similar concept of schema of the data and migrating that schema to a newer version when the logic has updated. And it's like applicable. As soon as you learn that, it doesn't freaking matter whether you are an enterprise backend database developer or a game developer. It doesn't fucking matter. It is a universal knowledge. This is what I'm talking about. This is what you should learn. Programming is universal. So, and I don't personally, maybe I'm coming from a different culture, but personally I do not understand this hyper specialization Like, I'm a React developer and I don't know anything about your graphical stuff. I'm a React developer. Like, it's just like, it sounds to me like, I'm a for loop developer. I know nothing about your while loops. Right, I know nothing. I have a certificate that I'm a for loop developer. If conditions, proceed. I know nothing about that. I'm a for loop. Like, this is how it sounds to me. This hyper specialization, like, I personally do not understand that. Like, why you're hyper specializing on these things. So maybe I'm weird, like, I don't know. But that's how it sounds to me. When people say, I'm a React developer, that sounds to me, I'm a for loop developer. Like, why are you hyper specializing on this thing? Anyways, so we got some subs. Thank you so much, Azeros, for Twitch Prime. Thank you with the message. Love you, streams. Thank you. Overfitting programming rules, yeah. So overfitting. So Yusu, kawaii freaking adesso. But I'm not sure if we're gonna be implementing it right now, and I'm not really sure if this kind of approach is actually fitting for what we're trying to do right now. But this is something just to keep at the back of our heads. At the back of our heads. Okay, guys. So this is what we're gonna keep in here, and I think the time has come to implement plug init and plug frame. I kind of want to call it plug update, right? Since the state is the plug, we are initializing it and then we're updating it, right? Initializing and updating. Okay, so let me copy paste this entire thing, and I'm gonna just like straight up, define them. So this is gonna be just this, and the update is going to be just like this, so what we're gonna do in the initialization, well, first of all, we're gonna compute pi, right? So we're gonna compute pi, and not only compute pi, we're gonna actually save it in the plugin, right? Plugin is going to have its own version of pi. So another thing that we want to probably have in here is the loading the music, right? So let's actually go ahead and just like load the music. So we also attached audio stream processor. This one is rather interesting, right? So that means we need to have some sort of internal callback. Anyway, so let me actually do that. So this is the music. The plugin contains the music. So the file path, suppose we accept the file path through command line arguments. So that means that init should also accept the file path, right? Because it accepts the file path of the file that it needs to load, right? So that means here we're gonna be accepting plug.c, so this is gonna be the file path. This is the file path. But to be fair, it would be kind of cool if the Musicalizer would accept files via drag and drop, right? So so it would be kind of cool that you open like a file manager and just drag and drop the audio file there, and it just like starts visualizing and stuff like that and playing. So I think that will be actually useful. And to be fair, this kind of stuff, it's only needed when we are in sort of like a development mode, right? I think we should also have like a separate build that links all of that statically and disables hot reloading. But in the debug, in the development mode, it actually decouples all of that stuff and lets you hot reload things, so we can iterate quickly on visuals and stuff like that. Excuse me. All right. So I think I need to, yeah, we need to go through this entire stuff. So because music now part of the plugin, so let's go and put it like that. So plug and plug. So this is that. and plug arrow. So we then start playing the music. Do we really want to start playing the music? I think that makes sense to actually start playing the music. And we're also doing the callback. So that means, by the way, the callback must be part. The callback must be part of the DLL. So, and when you hot reload the callback, how do you reset it? And especially, it's rather interesting when I okay, so let's not go there for too deep. We'll see if it will cause any problems, but that will be interesting, right? So I'm actually really curious what kind of problems we're going to have there. But yeah, so when we initialize the plugin, we just load in the music, we start playing the music, and so on and so forth. I think it makes sense to actually set the volume before we start playing. Right, so yeah, that's basically the initialization of the plugin. So, and the actual frame in here, right, it's the entirety of this thing, I suppose, right, the entirety of this thing. So this is the frame, and we just literally update the music that we do have in the plugin, right? Then we're just doing the controls, and then we're just rendering everything. So that's basically it. Something went horribly wrong, I don't really know why, but it's, yeah, can I? Yeah, I can probably do something like this. There we go. Cool. So I suppose after that, we need to load all of the necessary functions in here, right? So in plug, we only need libinit and libupdate. So let's go ahead and introduce them. So we're going to have init and update, libinit and libupdate. So we also need to load them from the library. So I'm going to copy paste all of these things in here, and I'm going to just query replace this stuff like that. So this one has to be libinit, so I probably don't need that stuff anymore. It would be kind of nice to have like a separate function that just, you know, tucks all of this repeating code under function call, but I'm not sure how exactly to do that. So this is init and this is update, and there we go. We successfully loaded all of the necessary functions. Okay, so we're not going to have pi in here. We are initializing the window, we're setting FPS, and we initializing the audio device. And this is where we're starting like initializing the plugin. So we probably want to have maybe plugin allocated somewhere, maybe in a static memory. Let's introduce something like plug. Plug, actually, without any pointer, we're just like literally gonna allocate this thing in a static memory, right? So we're just allocating it in a static memory. So after that, we just do plug init, and we just do it like this. And after that, so we're rendering the frame, and then plug update plug. That's everything that I want you to have in here. Right, so we have a global variable plug that contains the state of the plugin, the state of the whole application. We initializing it before the main event loop, and then in the main event loop we keep calling this thing. So we didn't really put everything into the DLL. So the more we put under the DLL, the more we can actually hot reload. But I decided to stop at this specific part, right? So essentially the event loop is in the main program, but the whole logic is going to be in a separate DLL. So something like that. And in here, we're probably going to have a thing that hot reloads things. For instance, if is key pressed key, let's say R, hot reload this entire thing. Specifically, DL close lib plug, just like straight up DL close, and repeat this entire code. So, which probably means that we want to put that into a separate function. so it's easier to load and stuff like that. So, and maybe these kind of things has to be global, right? So the file name and the libplug itself, something like this. And maybe we want to have a function something like reload libplug. And this is what we're going to do all of that, right? So I'm going to actually take this entire stuff, the loading of the library, and then finding all of the symbols and stuff like that. So this thing is already global, and this thing is also already global, and look at that. So in here, we actually return 1 in case of an error. So we can actually try to return Boolean, and here, in case of an error, we're going to return false. So return false, 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 but if everything went okay, we're going to return true. So, and essentially here, the first thing we want to do, we want to reload libplug. Reload libplug. Interestingly, so what we need to do, if this thing was called, we close libplug and just reload libplug. But since we are reloading, maybe we need to tuck DL close under the reload plug. So essentially we can do something like if libplug is not null, right, not equal to null, we just close it, right, we just close it. So and essentially it's safe to call this function several times, and every time you call to this, it's gonna reload. Interestingly, so if we couldn't reload, should we just crash? Right, so we can definitely do something like if not, just return 1. So we can do something like that. So if not, return 1, so basically crash instantly. So that's one of the things we can do. Right. It's one of the things we can do. And yeah, so let's actually try to compile this entire thing. We've been modifying this thing without recompilation for quite some time. I'm pretty sure we have a bunch of errors that needs to be fixed. Thank you Azeros for Twitch Prime. I hope I acknowledge you with the message love your streams. Yeah, I think I acknowledged that. I forgot that I acknowledged that. All right, so let's just go ahead and do that. So let me see. Okay, so we don't have complex in here. So one of the things we probably want to do, we want to include complex numbers, right? But we are using complex numbers for FFT, right? So this is very important. Do we need to reload on every frame? No, not really. So we're not really reloading on every frame. We're only reloading if on that specific frame the user pressed R. So this thing is true not on every frame. It's only true on the frame where we pressed R. So it doesn't need to be reloaded every time. So it's just like we're seeing if the user pressed R, only then we're hot reloading this entire stuff. Okay, so yes. Let's go ahead and do that. So music, that means we need to include raylib, right? So both of the things, they use raylib. A turn to F, so that means we need to have math. So math is really important. Assert, that means we need to have assert. So callback. Okay, so we don't have a callback in the plugin, but we do have the callback in the main application. Right, so one of the things we need to do in here. Ooh, and this is actually a little bit annoying because the callback doesn't accept user data. Yeah, this is a flaw in the design of Raylib. Because I'm pretty sure in SDL there is a pointer to user data. So so if we move this entire stuff in here, man, this is annoying. This is actually annoying. So if we take a look, SDL audio callback. SDL audio spec. I think this is how, yeah, there we go. So this is the structure, right? If I go to the definition of user, like SDL2, and let's grep for SDL audio spec, and I should have actually capitalized that properly. So here's the definition of the structure. So you have an audio callback and you have a user data passed to callback. And if we take a look at the definition of this thing, so this is your user data. So you can associate some user data with the audio callback and stuff like that. But in case of ArrayLib, it is not the case. You don't have this association. And if I had this kind of like user data, I would have actually put plugin in there, so I have an access to in. But because ArrayLib in this specific area is not particularly designed well, unfortunately, I probably will have to have global. Yeah, I'll have to have this global array in. So plug.h. Yeah, there we go. So this is a huge problem, right? So this is a huge problem. This thing has to be a global data like this. It just has to be a global data, unfortunately. But maybe this is something to contribute to ArrayLib, or maybe there is a reason for that, because callback is kind of called in a separate thread, right? So it's called in the audio thread, and because of that, so yeah. Wow, even Windows and Mac audio callbacks accept user data. That's an ugly side of ArrayLib. Yeah, so there is a little bit of an ugly stuff in specifically audio part. So yeah. So don't you get the data buffer as an argument in callback? Actually, buffer data is the samples. So yeah. So there's no room for that. But maybe okay. So let me see. So the way we actually do all of that, we attach processor. Yeah. So this is how we attach. So we supply the stream. And we supply the callback. So let's take a look at the implementation of attach audio stream processor. So we can take a look at software, ArrayLib, and what I want to do, I actually want to find implementation for this thing. Okay, so here is the implementation. Cool. So it specifies the processor and it just like assigns this processor. So oh, it's funny how it like literally allocates something and then just adds the processor. So, and then the processor. Oh, are you telling me that this is like a... Is this like a linked list of processors? This is very funny. The audio part of ArrayLib is really a sus, not gonna lie. But maybe this is how you do the audio stuff in ArrayLib. Like I'm not really an audio developer, so yeah, maybe that's fine. It's just like kind of a bit weird, not gonna lie. So let me find the definition of our audio processors. So yeah, so it's just like it just stores the processor callback. Yeah, it's a linked list and everything. Linked list strike again. So I suppose in this specific case they're convenient because you can just like allocate them then. But man, that is yeah. And data buffer on music stream keeps filling. Yeah, this is a little bit of an ugly API, not gonna lie. So are we thinking about a hack to pass a point? of audio sample, then our callback and does the mess. I don't think so. I don't really want to, you know, hack anything right now, to be fair. I don't really want to hack anything right now. What I want to do is just like get something working. So because of that, I'm going to keep in as a global variable, right? So I'm going to keep in as a global variable. So, and to be fair, in the callback, I don't really want to do FFT, right? Because all of that is a separate thread. So yeah, whatever. So maybe I'm going to actually move FFT to this thing. Yeah, that will be actually kind of fine. So we can do it like that. We do FFT in, but plug is out. And that also automatically means that we don't really need to have max amp like a part of the plugin, right? So yeah, there we go. So this is the output and everything. And to be fair, yeah, so I suppose we'll need to keep both of these things like that. Yeah, so this is the part of the data that is not particularly hot reloadable. So yeah, I guess we'll have to deal with that. We'll have to deal with that. Pi is hot reloadable though, right? Pi is hot reloadable. Okay, so let's try to rebuild this entire thing. Go to the compilation errors. So frame, the definition of the frame. I need to also copy paste this stuff here. So this is going to be the frame. I'm effectively moving everything to plugin. So what's the other things? So this is a plug music, plug music, plug music. What else do we have? FFT. Okay, so maybe I'm gonna move FFT to a separate sort of like a header, or maybe Mutualizer. Yeah, maybe Mutualizer doesn't even need this stuff, right? So we actually want to move a lot of things in here, like a lot of the logic just moves there. So we have pi, which is a plug pi. You know what? I think this pi as a separate variable is dumb. So what I'm gonna do, I'm gonna just define pi. Right. Wait a second. I don't have to do that. ArrayLib has its own pi. What the fuck am I even thinking about? So literally, Fortran damaged my brain irreversibly. Like, holy shit. I think somebody actually said that Fortran damages your brain, and this is true. I actually feel that effect on myself right now. So, like, if you take a look at the ArrayLib, there is, like, here's the pi. Like, what the fuck am I even thinking about? Like, holy shit, Fortran. Should have not programmed for 2 weeks in Fortran. Okay, so you don't freaking need that pi. Like, come on. The only thing you need here is music. So we actually removed almost everything. So maybe at some point we're gonna also remove music, and you don't actually need this kind of like a structure anymore. But that's fine, by the way. That's the software design process. You keep sort of discovering things as you go, and you keep updating the requirement. That is totally normal. That is totally normal that you had like these kind of initial assumptions, and at the end of the development, like it's completely different. It is okay. It is okay. Right, so it's just like at the beginning of the development, you didn't have enough information, and as you were developing, you were gathering information, and yeah. So okay, so let's actually keep rebuilding this entire stuff. So just like use pi, bruv. You don't have to do that. All right, so this is just out. So then we do update, and this is the frames, and frames is essentially, yeah, so we're just like iterating through and there we go. So now we are having compilation errors in the main program, but they're easy to fix because we don't need to like all of this shit in the main program anyway. So I'm gonna just keep removing the code until it compiles. That's a good strategy. So if you have any compilation error, just keep removing the code until it compiles, right? Until you have an empty file compiles. Actually, it does not. But it depends on how you compile it. So I'm pretty sure if you just like touch foo and you try to compile foo with gcc -c, it will successfully compile. So, and you even have an object file that doesn't even have any symbols. It's literally an empty file and its size 920 bytes. Like, what does it even fucking contain? I don't freaking know. It was literally compiled from a C file, which is 0 bytes. But somehow we compiled 0 bytes into 920 bytes. Magic. I don't know how that happens, but that's the magic of GCC, I suppose. Bloat, literally bloat. Anyway. So let's keep removing the code until this scheisse compiles. So we don't. Yeah. So okay. So this is a real library. Do we need anything else? I think it should just work now, right? So let me try to rebuild this entire thing. So plugin init. Too few arguments. We also have to provide the file path. So this is going to be the file path. There we go, and it's compiled. This shit just compiled. So the main program actually is like this. So we have hot reloading stuff. This is the code related to hot reloading, and this is the main program. All of the logic was moved into the plugin. Right. So this is the entirety of the logic, and it's hot reloadable. It is hot reloadable. Right. So I'm actually a little bit scared. I don't know if it's going to work or not, but we are about to find out. We're about to find out. So different background this time. Yeah, I actually moved to a different apartment. I keep teleporting between different apartments like every stream. Anyways, so let's go ahead and just try to run Mutualizer, and we're gonna run it on some music. So OGG. So we can't find this thing, so we have to do LD library path. And what we're gonna do in here is, I suppose, build and segfault. It managed to compile this entire stuff, right? So it managed to compile this entire stuff. In fact, it initialized everything, so failed to create data conversion pipeline. Stream doesn't really explain why though. So it successfully loaded the music though. So I have a suspicion that this is because we statically linked with the Raylib. Right. So we statically link with the Raylib. Maybe I need to, let's actually try to rebuild Raylib to be dynamic one. So luckily we build Raylib from scratch and we can afford that. So if I remember correctly, so it has an option literally to compile like a shared, there we go. So you can just do shared libs, and we can just do on, and let's just go ahead and rebuild this entire thing. So how are you guys doing? How are you guys doing? So we're just waiting until Raylib rebuilds itself. Even if you dynamically link, you will still have different for main program and plugin though? No, I don't think so. I think it's will mean that they both gonna use the same SO file. Yeah, different Raylib context, right? Because Raylib stores its state in a global variable, so yeah, we kind of need to share this kind of thing. Don't you need to run CMake again? No, you don't have to. So it detected automatically that I modified CMake cache. It reconfigured it automatically, and it actually rebuilt only relevant things in here. Right. So, and now if I try to do make install, it installed raylib.so. So that's the beauty of CMake, is that it tries to just like, keep track of everything, right? It keeps track of everything. If anything is modified, it tries to sort of, reconfigure and stuff like that. But that's kind of deceiving. It's kind of deceiving. It works in 99.999% of the time, but then it may bug out. But since it already trained you to think that it always like does the incremental build perfectly, you may spend a lot of time just finding the error where it doesn't exist, and it's going to be error related to incremental compilation. So it's just like, I don't know. I've had problems like that with Raylib. It works relatively well. It works better than just like manually crafted makefile, but sometimes in my case it works 30% of the time. Okay, it's even worse than but it definitely works better than manually crafted makefile, because in case of manually crafted makefiles, it's difficult to basically encode all of the dependencies properly and accurately, and especially update them accurately. So you can use things like GCC minus capital M that generates dependencies for you, but it's still just like, I don't know. So what I find useful these days is to actually not increase the complexity of the build system, but actually decrease it, right? So these days I went back to build.sh files, and it just works for me. I just try to not overbloat the build system right away. I just try to keep it simple and I don't add complexity unless it's like absolutely needed. Unless it's absolutely needed. All right, so we have a raylib.so. In fact, I would probably like to remove raylib because I feel like it actually installed. Yeah, it still has the previous. It has the previous version. So this is the static library, and it was installed on July 15th, and this is the latest one. So I'm gonna go ahead and just remove raylib completely from my opt folder, and I'm gonna try to install it one more time. Alright, I'm just gonna go here. So here's the raylib, and it only has raylib.so. Raylib.so. Okay, then. So let me go to the build. Mutualizer. So mutualizer. Let's try to build it now. Is it going to work? It seems to be working. It seems to be twerking. So if now I take a look at LDD. Raylib. Oh man. So we'll also have to update LD library path so it finds Raylib. Yeah. But at least, as you can see, it actually like linked it dynamically, right? So it linked this entire thing dynamically. And if we take a look at the libplug, it also linked this thing dynamically. So my hope is that they're gonna be using the same dynamic library, right? So both of these things, the main application and the libplug.so, they all try to find Raylib as a dynamic library, right? So, okay, so if I try to now run this entire stuff, right, it's not going to work because it can't find Raylib. I just realized Raylib. Raylib. Okay, so I have an idea. So I have a thing called environment files, and in environment files I essentially update environment variables, right? And the way I use environment files is that I put dot, and then I take the environment file raylib.env, and I sort of enter the development environment. You know, you can't really see that, but this is basically what I do, and that updates all of the environment variables. And now I can use this locally built, locally installed library, right? Because as you can see, it's OPT, but it's inside of home. That's some Nix shit. Yeah, I've been using Nix for 5 years, and it's irreversibly damaged my brain. Yes. So I've used a lot of technologies, so you don't have to, right? I used NixOS, and it irreversibly damaged my brain, and now I'm thinking about these environment variables. I used Fortran and it irreversibly damaged my brain. Now I want to compute pi at runtime, right? So depending on the precision of your float, I don't know why, it's kind of pointless. Why the fuck would you do that? But Fortran, man, it's just like, it scars you. It scars you for the rest of your life. So anyway, and on top of just installing, like setting up package config stuff, I think we can also set up LD library path, and we can say, okay, just use home, so we can do opt lib, right? And we're gonna append it to this thing. There we go. So, and what I'm gonna do in here is just like, I'm gonna call this thing one more time, and I'm gonna echo LD library path, and this is my LD library path. Maybe on top of having that, right, I also gonna say search within the build as well. So, and if I do LDD Mutualizer, does it find any of these libraries? So it found raylib in here, and does it find lib plug? Where is the plug? I don't see the plug mate. Do you guys see the plug? I think I can't really search it for some reason, but I suppose it can find it. Okay, so oh, DL open. Oh my god, yeah, I'm just like, I'm so tired. Anyways, so if we try to do this kind of scheiße, right, if I try to just call, I probably need to also restart Emacs from within the new development environment. That's very important. That is very important, meine Freunde, very important. So let's do Mutualizer, and I'm going to do the music, the Tower of the Dreams. Now chat, get ready to get blown the fuck away. Where do we render those goddamn rectangles? Where do we render them? Well, we render them in the plug.c. How do we render them? We actually call to draw rectangle, and we set the color to green. All right, I just modified the color. I'm just modified the color green. Now, can your Python, JavaScript, or any of these toy scripting languages do that? Freaking easy. This is technology from 70s. Easy peasy, lemon fucking squeeze. That's how we do that, right? So it's a very old technology. There's nothing special about it. So you can do all of that in C. So that's very cool. And now we can actually work on this thing without really restarting it. Though I wish I could make input and output part of the context, but that requires to actually pass in user data to the callback. So yeah, I'm already streaming for like 1.5 hours. So I think the time has come to make a small break, and after the small break I would like to maybe fix the visualization of this thing, right? Because the visualization right now is kind of scuffed. You know why it is scuffed? Because this is not how we perceive the frequencies. I was actually told about that in the comment section of my previous stream, right? I uploaded this stream on YouTube, so it's gonna be in the description. the link to the playlist and stuff like that. And somebody actually noticed, brought to my attention a very interesting thing, is that we do not perceive the frequencies linearly, right? So essentially I display all of the frequencies in here like linearly. But this is not how we perceive them. Essentially, we perceive lower frequency closer to each other, but higher frequency more apart from each other. So, and this is how how the different sound application actually visualize the frequency, right? So they visualize them on a logarithmic scale. And furthermore, so if you take a look at how essentially you compute the frequencies of the notes, right? If you look at how you compute the frequencies of the notes, I actually prepared a little bit for the stream. So in the description, you'll find a link to note frequency map, right? So this is basically the page. I'm going to copy paste it in the chat, and right, for people on YouTube, it's going to be in the description. So, and essentially, how do you compute a frequency of a specific node, right? So you want to play a note, and what's the frequency of that node? So let's denote the frequency of nth node as Fn. The first thing you have to do, you have to define the base frequency relative to which you're actually sort of like computing everything. Is going to be F0. And then you multiply it by some sort of a in the power of n. And a is basically like, some sort of a value, like 1.06. And essentially, like each individual node is computed by multiplying by 1.06. Right, so the first node is going to be like base frequency, the next node is going to be multiplied by 1.06, the next one multiplied by 1.06 again and again and again. You don't add this step, you multiply by this step. So the next nodes are farther and farther away, because this is how we perceive the frequencies, right? And this is basically what you need to do if you want to visualize them. So instead of visualizing them linearly, you actually traverse them by multiplying by this step, right? So here we iterating them by doing +1, but maybe we have to iterate them by multiplying by 2 or multiplying by 1.5 or something like that. And if you do that, it's gonna look a little bit better. So I can even probably visualize stuff like this, right? So essentially we have frequencies like this. Right, so this is array of frequencies. This is array of frequencies. And essentially what we have to do, we have to display this frequency first, then this frequency, then multiply by another step like this one, then another one that is farther away, and then another one that further away, and so on and so forth. So this is how we have to sort of like display them. But that creates a very interesting situation. It creates these constantly growing chunks. And some of the frequencies are going to be missed, right? Some of the frequencies are going to be missed in here. Maybe there is like a very high frequency in here, but it's kind of like something between this one and this one. So instead of just displaying these samples alone, maybe we'll have to actually display an average of the frequencies of these chunks. You know what I mean? Right, so we will have to display an average of that as a single bar, and maybe an average of that as a single bar, and so on and so forth. So that's basically the idea of visualization. I don't know if it's going to work, but we'll see. The winner gets tea. So yeah, and by the way, if you like this song, it was created by a very cool chiptune artist by the nickname Null. You can find all of their socials in here. So if you do song command, so you can find more songs like that in here. And for people on YouTube, it's going to be in the description, right? So they're very cool. I really like their songs. Okay, so let's make a small break, and after the break, we'll try to sort of fix this visualization, and we'll see how it goes. Alright, we're back to back, champions of the arena. So let's actually see what we can do in here. So we have n So an n is for some reason in the header, even though in header we don't really refer to n. And n is basically the amount of samples we're working with. So 256 is basically the size of the buffer, right? So this is the size of the buffer that we're working with. And what do we want to do? I want to have a bigger buffer, right? I want to have a bigger buffer because, so essentially each sort of cell in out measures a specific frequency. So we can only measure the frequency starting from 0. We do measure the zeroth frequency, right? Because this is how FET works, up until 256. And that's not really high frequencies, right? Because what's the like hearable range of frequencies? Probably have to go to the Google, right? 20 hertz to 20 kilohertz. So we need a power of 2 that is close to 2000, right? And 256 is just like not enough. Like we need to have more frequencies in here. We need to measure more frequencies. So, and this is probably something that we'll need to do. Okay, so 2 to the power of 10, 13, 14. That's very close. 15. Yeah, maybe something like 15, but it's too much. Yes. Maybe we can say. So I'm just like a little bit afraid that the FFT is gonna go too long, right? And we have to do that on each frame. So we have to do that on each frame. So let me see. And I have a fly in here. So let's do 14 just in case, just to be safe. All right, just to be safe. All right, and if I try to now rebuild this entire stuff, so plugin is not saved properly. By the way, we're listening to some music, not approved music, so let's actually turn it off. And let me try to rebuild this entire stuff. Okay, so let's go to the compilation errors and so indirect requirement. Oh yeah, so I suppose to actually do it like that. Freaking, this is a Fortran again. So I'm gonna tell you a secret. I've been programming in Fortran right before the stream. I was solving Project Euler problems in Fortran. So don't ask me why, right? So it's just none of your business. I can do whatever the fuck I want in privacy, right? Even programming in Fortran, none of your business. And in Fortran, like this is how you do powers, right? And yet again, Fortran irreversibly damaged my brain. So what I want you to do in here is actually I want you to do a shift, right? Like this. Yeah. That's what I want you to do. And it does in fact compile. So let me try to run the Mutualizer. So we're starting the Mutualizer, the Tower of Dreams, and let's go. We are playing the music. We can't see Scheiße in this mist. We can't see Just a second, one more time. There we go. So we can't see Scheiße because we have too many goddamn samples. Too many goddamn samples. So one of the things we probably want to do, right, is increase the width or fixate the width of the bar. So essentially what we do, we take the width of the window and divide it by the amount of samples. Since the width of the window is smaller than the amount of samples, the cell width become less than 1 pixel, so you can't see Scheiße. So one of the way I actually solve this thing, I set this thing to maybe 2 pixels, right? So they're gonna overlap, but at least they're gonna be visible, right? So they're gonna overlap, but at least they're gonna be visible. So we're gonna rebuild this entire thing, and I'm gonna refresh, and we can see Scheiße. This looks fucking cool, actually. So these are the frequencies. So we don't even use the width or anything like that. So we can even pause this entire thing if we want to. I'm surprised that it's so freaking smooth. Right. I'm surprised it is so smooth. And let me actually see. So I can even change some of this stuff. I wonder if I can change the color depending on the amplitude. Can I do that actually? So the amplitude is supposed to be from 0 to 1 because we're dividing it by the maximum amplitude. So is there anything in Raylib that will allow me to mix this stuff? So color, blend, I remember there was something for blending. So there was a color alpha, I remember that function. And then, okay, so you can blend this thing. So tint, you can add a little bit of a tint. So alpha blend. All right. So I think I need to do a combination of these two functions. That's probably what I have to do. So let me see. So and essentially I can take the color and say red. So the higher the value is, the maybe smaller the alpha should be. But maybe because of this I need to do red. So green. And so let me just find this stuff. And alpha, I'm gonna set T to the alpha, right? So we've got that. Then we're blending this entire stuff. So the SRC is gonna be this, but the base color is gonna be red. So the bigger it is, the less alpha it's going to have. So it's gonna go from I think red to green. Right, red to green. So which is kind of weird, but we'll try to fix that a little bit later. Right, so so let's actually plug this entire thing to the color of this entire stuff. So it's going to be C. And if I try to compile this entire stuff, it crashed. Yeah, it segfaulted. Nice. Right. Why did it segfault? I have no idea. Right, so let's try to run this entire. So yeah, this is what I was trying to do. I don't know why it segfaulted, but it actually did. So let's actually maybe do green. Can I? It's kind of weird why it segfaulted. Yeah, it literally segfaulted. Huh. There's no really reason for that to segfault, right? Because I just changed the color, because just changing the color should not be a reason to fail, I think. I don't think so, right? So if I do that, yeah, as you can see, I can change color just fine. So that's totally fine. Alright, anyway. So one of the things we want to do, we probably want to, you know, display in a logarithmic scale, if that makes any sense. Maybe the address of in changed when reloading. Well, maybe, but why didn't it change when I changed the color in here? Oh, maybe because the code modified in here. So essentially, if I do something like this, right? So if I do something like this, and no, it doesn't really change anything. Could be. So I added new variable, probably. So anyway, yeah, it would be better if this stuff was actually part of the context, but like Raylib doesn't allow us to do that. Raylib literally doesn't allow us to do that, and maybe we can hack Raylib at some point. So we'll see. So first, like, we need to logarithmically jump, like, over a certain period of samples, which creates a lot of like weird stuff. So first of all, we need to at least count how many samples we're going to have, right? Because we need to divide the width of the window by the amount of samples, right? So that's what we have to do. So the way I think we're gonna do that is essentially we can maybe do for loop, right? So we're gonna do float, and we're gonna start with the frequency, I think 1, right? So we're gonna start with the frequency 1. So I'm gonna ignore the frequency 0 because it's literally just the original signal itself. I didn't think it's particularly interesting. Or maybe we can actually start with the frequency 20. Right. So we can start with the frequency 20. The music reminds me of KGen chiptunes. Yeah, because that's basically what it is, right? So it's a chiptune. So if you really like this music, check out the author of this song, right? So you can find their socials and stuff like that here in the chat. Right? So you'll find more of their work there. Okay, so essentially what we want to do, we want to go with that frequency while it's less than amount of samples, right? So maybe it'll also make sense to actually cast it to size t. And the way we're gonna iterate through all of that, we're gonna basically multiply it by this step, right? In our case, we can use the same step as in the music formula in there, right? So it's basically what's the value? 1.06, right? So we can probably round it up. Right, so this is going to be 6, and there we go. And we can just like count how many of these things we encounter, right? I think that's the easiest way to do that. Even though it's kind of dumb, I realize that, but I'm just a little bit too lazy right now to properly do that. Right. So yeah, that's cool. So and then I'll be able to do some stuff like divide by m, because that's the actual amount of samples we have. Right, and that's gonna be rather interesting. So I want you to actually take like an average of the amplitudes of the frequencies in a certain chunk, but I think for now I'm gonna just display the frequencies. I'm just like sample the frequencies, like whatever f lands on, this is what we're going to be displaying there, right? So that's basically the idea. So in here we're going to be iterating not from like I to n, but starting from f and up until it's bigger than n or whatever. So, and the I in that specific case is going to be essentially, all right, maybe we want to reset m, right? And instead of I, at least in here we're going to use m, and m is going to be +1, right? Because we only need m to divide by the size of the window, right? So to know how many samples we have in there, so that's fine. So here we're taking f, but we cast it to t. So out actually stores the frequencies, and the corresponding amplitude of the frequency is the index, right? So this is what we're going to be doing in here. So we might as well maybe even floorf it, just like round it down. I'm not sure if that's super important, but that's one of the things we can do. And that's basically everything I wanted to do, right? So that will, yeah, it's segfaulted again. And I feel like this is probably because of this specific thing, right? If it was in the, all right. In like part of the context, and we could pass the context there, so kind of defeats the whole point of hot reloading, but yeah, it's kind of sad game. Oh, look at that. Pretty cool. That's probably why segfaults had the same thing. Okay, so it's probably a common thing. So how can we work around that? There's no way to work around that unless unless you allow the user pointer, the user data pointer in the callback. Like I don't see any other way to work around that. It's just like we literally have to hack the like raylib. So, but maybe that's something we can do because we already built the raylib from scratch. But I mean, it makes it kind of difficult to distribute and stuff. So let me see. So how can we actually take an average of these things, right? So because essentially This is an F, right? And I kind of need to keep track of the previous value, right? So I kind of need to keep track of the previous value. Because here I can do the following thing. I can do F1, which is going to be F multiplied by step, right? And essentially, I have F and F1, and like everything I have in between those things is subject to being averaged out. So, and effectively, how can I even do that? I can have a float Q, I can even do like something like size T. So here I do florf, but let's actually truncate because I don't think they're negative. Yeah, they're definitely not negative, so it doesn't matter. So this is size T, and then Q, I suppose it could be less than that, and we just like iterate. So then we can accumulate the amplitude, so let's actually call it A, right, so let's actually call it A. And essentially, I just take this stuff, so this is Q, and I just add it, so I'm accumulating the amplitude. Alright, and then I need to define it, divide it by some sort of a value, but the question is what's going to be the value? I suppose it's that, subtract that, plus 1, right, so, and that is basically it. So since it's an amplitude, we want to divide it by the maximum amplitude. And yeah, so we go to the next step, and it only makes sense. So we have to be super careful because Q at this point can go over N accidentally. So we may want to also check that something like this, right? Something like this, just to be 100% sure. So, and yeah, essentially we're just like averaging out these chunks, right? Because I'm just afraid that we might be losing a lot of information if we just like only pick these samples and display these samples. Though, like, look, this thing kind of looks smooth enough, but oh yeah, at the beginning it looks smooth, but as it goes towards the end, it looks less smooth because we're losing information. It literally explains this. It actually explains the behavior of this thing really well. That's kind of cool. Okay, so that makes a lot of sense. So let's try to recompile this entire thing and see if it's going to work. So I'm gonna try to, yeah, it still doesn't work. So we have to. So does it look believable? It would be kind of also cool if we could animate that. It kind of looks believable, I think. So essentially, basically, you have a state of the frequencies, right? You have a state of frequencies, then you compute the next one, and instead of just flipping from one to another, you just interpolate, like visually interpolate between them. So the left is low and the right is high. So maybe could we kind of slow down this entire thing? I wonder. So what if we reduce the amount of samples? That's something we can do. A lot of bass in that song. Yeah, there is quite a few bass. So if we keep reducing up until like 10, what if I do 15? So that's a lot of stuff. Is the audio callback called in a separate thread? Maybe that's the problem. Yeah, it is called probably in a separate thread. I vaguely looked into the arraylib. I think it is called in a separate thread. So it might be necessary to stop audio processor before DL close and start it after reloading. We can try to maybe do that. So I don't really know how to stop. Maybe like pause the music? Maybe not. I don't know. I'll look into that maybe off screen. Alright, so I'm already streaming for more than 2 hours and I think I already achieved everything I wanted to achieve today, right? I essentially implemented the hot reloading. I made like logarithmic scale for the equalizer and stuff like that. And yeah, so I'm gonna continue working on this thing off screen, and if there will be interesting topic, I'll stream it. I'll schedule it as usual. So that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Azuzi. I love you all. Mwah. Alright, this is the next day, and as a footnote for this session, I would like to explore the idea of resetting the audio callback processor and see if it actually fixes the segmentation fault, because there is a strong evidence that it probably will. Right, because when we are reloading the shared library, the address of that callback changes. So essentially, the audio processor or the audio code of the arraylib tries to call to a function that doesn't exist anymore. Right. Sometimes it does, right? So in case when nothing much changed within the code, and we saw that by changing the core and stuff like that, changing the core of the thing didn't really crash. But if we do any significant changes, right, it starts to crash. All right. So let's actually try to reproduce this entire thing and see if it's going to do that. So we rebuild this entire thing, and let me try to run the Mutualizer, and I'm gonna provide the music, the Tower of Dreams, OGG, and let us see if it works. So it's actually going pretty crazy, huh? Interesting. So let me try to do some modifications and like try to maybe, you know, crash it. So if I do green, right, if I do green and I try to... Did I actually start it in the compilation mode? Yeah, unfortunately I did, so I actually need to start it slightly differently because of Emacs things, right? So it has nothing to do with the application itself, it's just like how you use Emacs. So the compilation mode doesn't allow you to start several compilations, which is kind of weird. Maybe it does, but by default it doesn't, right? So, and if you want to have like a you know, several processes, you have to use a different mechanism of running external programs from Emacs. It's just like Emacs being Emacs, nothing particularly special, right? Right, so let me actually start it with the different mechanism of running external applications, and now I should be able to rebuild the thing. And if I try to do that, as you can see, it works because we just changed the, you know, the color, right? It didn't really change the application too much. One of the things we may try to do is to maybe change the step itself, right? So maybe that will be a significant thing that will crash the application. No, it's not actually that significant. So I suppose maybe maybe commenting out like the whole loop in here will significantly change the application. Right, and that will crash. So as you can see, this entire thing segfaulted. Right, so essentially what we need to do, we need to detach the callback when we are about to reload the library. So the question is, how do we even do that? Right, so what I was thinking is that maybe in the main application, we would call a function that signals to our plugin that we're about to reload the plugin. Right, something like a plug pre-reload, and we just supply this entire thing, and that sort of signals the plugin that we are about to you know, reload the entire thing, and it gives it an opportunity to maybe detach some callbacks and stuff like that. Then we reload the library, and then we do post reload. So, and in the post reload, we're gonna attach a new callback, right? So essentially, we are just giving the information of what about to happen to the plugin. I think that makes sense, right? I think that's actually kind of good. So, and let's define those things in here. So initializer just initializes everything, like loads everything up, but pre-reload and post-reload actually don't really reload the data. They just do necessary technical work to not crash, I suppose, right? So maybe in the future we're gonna have more code in those sort of hooks. We'll see. So let me go ahead and just do that. So this is a type def pre-reload. It's going to accept just the plugin, and this one is going to be post-reload. So let's go ahead and implement those things. So where's the plug? Where's the plug? So this is where it is. Okay, so we have that. And in a pre-reload, I suppose what we're gonna do, we're gonna simply detach, right? So here we do attach and we do detach. We're just detaching this entire thing. And in the post reload, we're gonna attach it again. But in the post reload, we're attaching a different version of the callback. And by the way, this is kind of a good approach, I think, because it makes the callback hot reloadable as well. So that will allow me to modify things in here, and that will be hot reloadable. It will be kind of nice to actually pass like a custom pointer to the data in here, but I mean, it is what it is, and it isn't what it isn't. So maybe this is something for like one of the streams where I'm gonna try to hack Raylib and extend it. The more I use Raylib, the more I notice like different rough things about this library, right? So some underdesigned parts that probably not that many people use, but I would imagine that many people use sound, but maybe not on the level we do that. I don't know, probably. It's kind of weird. But maybe I just don't understand how to use this API. That could be also a possibility. Okay, so let's actually try to recompile this entire stuff. Redefinition of t. Yeah, there we go. So I forgot to remove the suffix t. So one of the problems we have in here is that we never really defined the global variables in here, right? So what we have to define pre-reload and a post-reload. Right, so this is going to be post-reload, but on top of that, we also need to, you know, physically load and like find the symbols and stuff like that. Right, so let me actually do this kind of stuff. I think that's it. So this is going to be pre-reload, and another one is going to be post-reload. There we go. So that should fix the problem. So now, if I try to run this entire thing, could not find, ooh, this is weird. Could not find pre-reload symbol. This is because I forgot to rebuild this entire thing? Yeah, I probably did, right, so that makes sense. it still says that we don't have a pre-reload, which is absolute bullshit, isn't it? So here is the plug pre-reload. I mean, just a second. Let me try to rebuild this one more time. And then I'm going to try to take a look at some of the symbols in here. So pre-reload and post-reload. Did I make a typo in some things somewhere? Let me try to do that one more time. Oh, okay. Copy pasting. Get freaking yeah. Never copy paste. Right. But I mean, it's just like we code it relatively quickly, right? So I swear to God, like I need to have some sort of a macro, you know, that takes all of that into account. I just like don't know how to even come up with such macro. Right, because there's still going to be a little bit of a duplicate even if I factor out this thing into a separate function, right? So there will be at least a duplicate on the level of variable name and the name that you pass to that function, right? So the only deduplication we're going to have is this and this, which is like, I mean, it reduces the surface of a mistake, but it would be nice if I just said, yeah, if I just had a list of functions, right, simply a list of these functions and that's it. Maybe I'll come up with some sort of a system that actually makes it a little bit easier, but I mean, it's for later. I don't really want to think about it too much. All right, so I'm going to try to run it, and as you can see, it seems to be working. It seems to be working, so that means I should be able to do significant changes within the plug.c, right? So I'm going to try to change the color for now, just to test things out. We're testing things out. So the music is still playing, right? So we're detaching, you know, and attaching the callback, and the music is still playing. So that's very important. So this is the stuff I can do now. Okay, it didn't crash, so that was the problem. That was literally the problem, and yeah, we figured it out. So thank you everyone in the chat who actually was pointing out at this entire thing. So yeah, so that was that, right? So that was that. Now we know. So one of the things I would like to maybe do, what if we, I don't know, what if we have some sort of a, because I think it's like modifying too fast. It is modifying too fast. What if I have some sort of a counter, a global counter, and I increment that counter on each frame? And for instance, I do FFT only on like even frame, right? What if I do FFT over on an even frame? Is it going to make it less crazy, maybe? In fact, I can just increase this value, so it's going to be a little bit choppier. Yeah, it actually slows it down, so what about like 10? Yeah. So, and all of that without restarting the application, so this is actually super cool, I really like that. Yeah, because if I do it like that, it's just like... Yeah, so the reason why it works so fast is probably because I don't have a Twitch opened, right? And my entire PC is not really slowing down that much, so that's probably the reason. So, and I just remembered, by the way, that the way we receive the data in a callback is not particularly correct, in my opinion, right? It is not particularly correct. So let me go there. So what we do, where's the callback? I can't see the callback. Yeah, we're just like copying whatever we have, right? So if we take a look at the buffer, let's say that in the buffer we have like 8 things in here. And essentially, right, essentially, if we receive some stuff in here, right, so this is the chunk that we received from the audio system. We just, you know, copy that chunk like this. And then we do FFT on this entire thing. So if there is like nothing in here, yeah, so it will affect the FFT. And if, for instance, we have more stuff in here, we basically only copy this part in here. which is not particularly like correct way of doing that in the first place, like generally. It is not particularly correct way of doing that. So what essentially we want to be able to do, right, so we want to have this sort of buffer, and essentially if I got some data, I want to kind of push that data at the end of the buffer, and if I get a little bit more data, I want to push that data like this. So I want this to be like a rolling window. So we get more and more data, and it just like rolls to the left, and it just overflows and like gets forgotten. So it's kind of like a ring buffer, in a sense, right? Kind of like a ring buffer, and that's probably what I want to do. So maybe I can quickly code that. So the buffer itself. Can I do something like very dumb, right? Because I don't really want to spend too much time on making it super smart. So essentially, I'm iterating through the frames that I get, right? What if I just do a mem move that moves this entire like chunk to the left by 1 byte, and then I copy like one frame like this, and I do that n times in sort of like in a loop, right? I know that it's kind of dumb, right? So, but I mean, it's gonna do exactly what I want, right? So let me see. So let me take a look at the buffer one more time. And essentially, I want to do a mem move. So the destination has to be the buffer, the base of the buffer. So the destination is going to be this. The source is going to be, yeah, +1, I suppose, right? So I think it's going to be +1. And we want to copy n-1, right? So we essentially take this entire chunk and we move it to here. So it's a very like a dumb thing and probably super slow, but I mean the computers are fast, so who cares? And after that, I want to take this left thing and I want to put it at the end, right? So maybe what I'm gonna do in here is just this. Could have just like, do it a little bit easier, but yeah. So and that will just slowly roll all of the data from right to left as we receive it from the audio system. And because of that, we don't really need this stuff anymore, right? So it doesn't really matter if we have too much. I wonder if it's gonna be slow. We'll see. So let me refresh this entire thing. So mem move, implicit declaration. So maybe I'm gonna do a string. Right, so let me do the string and let's try to... And it seems to be... Right, it's really weird. What is it doing even? Is it even doing the correct thing? I don't freaking know. Hard to tell. So, yeah. We're iterating the frames. So, let me take a look at the definition of mem move. So it's not supposed to be like this, that's for sure. It's not supposed to be like this. The destination and n, I know for a fact that n is the size. Goddamn CIA! I know that I sound like Terry, but I mean, I got a confusion between the bytes and elements yet freaking again. Alright. Size of in 0 or whatever, right? So that should probably work. It is lagging actually. Right, so maybe because we have too many things in here, so let me just reduce the amount of samples. I think it looks believable, finally. Kind of. We can keep decreasing the amount of samples. Is there any way for me to restart the music? Right, so let me actually make it a little bit louder for you. I I think it finally looks believable, holy shit. Alright, so let's actually make it even smaller. Yeah, I think on 13 it was a little bit better, right? So it's a little bit higher resolution. Okay, so I wonder how can you restart it, right? Because I want to be able to restart this entire thing. Include raylib. So music, play, music stream. So you can pause and you can resume. I suppose maybe it makes sense to stop and play it, right? So let's give it a try. So let's create a key. So on space we just like toggle, you know, this thing. So maybe is key pressed. So what we're gonna do in here? So we also have some keys in the visualizer. So the only key is R. So let's actually do Q. So and that will like restart the entire thing. So in here we're gonna stop music stream and then play music stream, right? And see if it's going to do. So I think it feels like it's lagging behind a little bit. So yeah, it probably needs to be implemented a little bit faster. Did you see that? When they actually started like to do like when it started to have like a lot of action, it actually got reflected in the. Oh, okay, that makes that absolutely makes sense. It's lagging behind a little bit, but it makes sense at least finally. Holy shit! I'm so happy. Right, it needs a little bit of iteration, it needs a little bit of a polish, but we have hot reloading, so iterating on that is actually super easy, so yeah. Oh my god, I love it, I absolutely love it. Alright, so this is finally it, right? So thank you so much for watching this session. I think this session was extremely educational, especially for me, right? I learned a lot of interesting things, and I hope you did too. So yeah, see you on the next recreational programming session.